Hello, Matthews Gatos here. In this video, we're going to be covering 6.2, but before I do that, I want to review 6.1 by some diploma examples. So in the first diploma example, where cos can't be 0 and sine can't be 0, we have three different trig expressions, and they each simplify to a single numeric value. And we want to put those trig expressions into order from smallest to biggest. So let's start with this one here, tan squared minus secant squared minus 1. So what I'm going to do is rewrite tan squared. That's one of my Pythagorean identities. Tan squared is the same as secant squared minus 1. So instead of having tan squared, I have secant squared minus 1, and that will be minus secant squared. And then that will all be minus 1. So I have secant squared, take away secant squared, that's gone. So I'm left with -1, take away -1, which is -2. So this has a value of -2. Okay, let's try the next one. Let's look at this one here. Tan theta cos theta over sine theta. So tan theta is the same as sine theta over cos theta. And that will be multiplied by cos theta. Let's just put that over 1. All over sine theta. So in the numerator, cos divided by cos is 1. So I'm left with sine theta over sine theta, and sine theta over sine theta is just 1. Okay, and then let's look at our last one here. Secant theta minus cosecant theta over cotan theta. So I'm just going to write this in terms of sines and cosines. So secant theta is 1 over cos theta minus cosecant is 1 over sine, and that will be over cotan, which is cos over sine. Okay, so to get rid of my denominator in the numerator, since I'm dividing by sine, I'm going to multiply by sine. And to be fair, if I multiply the top by sine, I need to also multiply the bottom by sine. That works out nicely because then those cancel and those cancel. So I would be left with 1 over cos theta minus 1 over cos theta, which is just 0. So putting these in order from smallest to biggest, the lowest value, that -2, is expression number 1. And then my next lowest value is the 0, which came from our last one. And then 1 is the highest, which came from expression number 2. Okay, let's look at another one here. So we have cotan x plus cosecant x over secant x plus 1. And we want to know which one is it equivalent to. So in other words, what the answer is. So let's write it in terms of sine and cosine. So cotan is the same as cos x over sine x plus cosecant is 1 over sine x. That will all be over secant x, which is 1 over cos x plus 1. So I have a whole bunch of fractions over fractions. So I want to get rid of my fractions. In the numerator, to get rid of my sine x, I would multiply this by sine, and to be fair, I multiply this by sine. So this gets rid of the numerators in my, or the denominators in my numerator, but in the denominator, I have this cos x I need to get rid of. So I'm also going to multiply top and bottom by cos x. So whenever you have fraction over a fraction, just multiply top and bottom to be fair by those fraction denominators. So applying this in, because I have to do distributive property. So the sine x's cancel and you're left with cos times cos, which is cos squared. Plus, distributing this in, the sines cancel, you're left with 1 plus 1 times cos is cos. In the denominator, distributing this in. So the coses cancel and you're left with sine x plus, and then sine x cos x times 1 is sine x cos x. Okay, so now I see in the numerator I have a common factor of cos x, so I'll just factor that out. And in the denominator I have a common factor of sine, and I'll factor that out. Oh, and I see something nice here. Cos x plus 1 is the same as 1 plus cos x, so those cancel, and I'm left with cos over sine, and cos over sine is just cotan. Okay, so that's a lot of work for just a multiple choice question, and it's totally fine to do it that way. I just want to show you an alternate way of doing it that you might not have thought of, and that's using your calculator. So in this question here, I could have put my question into y1. So remember, you only have a sine, cos, and tan button. Those are your primary trig ratios. So you have to write all other trig ratios in terms of that. So when I have the question that said cotan plus cosecant in the numerator, that's 1 over tan plus 1 over sine. And then divided by 1 over cos, because that's secant plus 1. Now, you wouldn't enter in all the options. You would kind of do them one at a time, but I just wanted to show you all the options. So y1 is the question, and these are all the potential answers. So one of these is the correct answer. So you're looking for which one matches to y1, and you can see that y1 and y5 are the same. So since y1 equals y5, D would be the answer because D went into y5. So just kind of another way that you could think about it. Okay, in this lesson here, we are going to look at sum, difference, and double angle identities. So a whole bunch more formulas that we're going to deal with. Now, some of the questions that we do are going to end up with a rational denominator. So in the curriculum it says students should be able to express exact values as answers with either a rationalized denominator or an unrationalized denominator. So in this lesson, I will do both. I will do unrationalized and rationalized, so you are familiar with doing both. So it's just kind of what we did in 20-1. Okay, so if I use the unit circle in quadrant number 1, or that hand trick for values of sine, cosine, tangent, secant, cosecant, and cotan, I have 6 ratios for those 3 different angles. Well, expanding that to a full unit circle and the cast rule, we know 6 exact values for all of those different angles. So those are all going to kind of come into play. So at this moment here, we have 16 different angles, 6 trig ratios, which means I have 9 exact values. But I can actually combine these angles together to create even more exact values. Like there's lots of different things that I could do. I could take 30 and 45. I could add those together, and now I can do an exact value for 75. Okay, I could also take 45 and 35, but I could, instead of adding them, I could subtract them. So if I subtracted them, I would end up with 15. So I can do something with an exact value for 15 degrees. Or it doesn't just have to be in quadrant number 1. I could take 120 and let's say 135. I could add those together, and then I could figure out an exact value for 255 degrees. So I could just keep on going with these. So combining these angles through adding and subtracting and even doubling, we can create more exact values. So this is the bulk of your formula sheet for 30-1. Lots and lots of different formulas. So we have sum and difference identities. We have double angle identities as well. So you do have the formula sheet. I just always like to look at a little trick so that I don't always have to rely on my formula sheet. If I'm looking at sine, angle sum and angle difference, so look, sine A plus B, notice that it's plus and it's plus, okay? But then there's a mixture of trigs. So see angle A, angle B, you have sine, cos, and then cosine. For subtracting, see it's subtracting, sine, cos, cosine. So you have mixed trig, same sign. In other words, adding, adding, subtracting, subtracting. For cosine, see how you have cos A plus B? Well, the plus becomes a minus. The minus becomes a plus, but the trig values are the same. Cos, cos, sine, sine. Cos, cos, sine, sine. So for these ones, I say that we have the same trig, mixed sign. Now, of course, tangent's kind of only in its own category. Then we have our double angle identities. You can take any angle in the unit circle, double it, and find that exact value using these formulas. So sine of 2x is just 2 sine cos. So it's a double mixed. Cos has 2 one, two, three different formulas, but notice there's always something that's squared in it. So cos squared minus sine squared, 2 cos squareds minus sine squared, 1 minus 2 sine squareds. So be on the lookout for that as well. And of course, tan 2x is its own kind of formula. So what we're going to do is we're going to do a whole bunch of questions where we're combining them by adding, subtracting, or even quite possibly doubling them. Now I want to focus on cos 2x for a minute because there are 3 different formulas to use, 3 different equations. So you really have to be choosy and choose wisely which one that you want to use. Here's kind of what I do. I use the first equation if I'm trying to simplify an expression where I want to get rid of a cos squared or a sine squared. I use formula number 2 if I wanted to get rid of a 1, because see, I'm minusing a 1. So if I wanted to get rid of a 1, I could combine that. And then I use formula 3 if I'm trying to get rid of a negative 1, because there's a positive. So positive and negative 1 kind of cancel. So choose wisely when it comes to cos of 2x and look at what you're given to see what you're trying to eliminate or simplify further. Okay, let's try some questions. So I want to write this expression as a single trig function and then find the exact value. So I have sine 100, cos 10, cos 100, sine 10. So see how 100, 10, 100, 10? Now these are a mixture of trig values. It's not the same trig value. So remember, sine is mixed trig, same sign. So I know this is a sine identity. So if I look at this, sine is mixed trig, same sign. Same sign meaning it's something minus something. So my angle A is the first one, 100. Angle B is my second one. So I can combine this as sine of 100 minus 10. Well, that's just sine of 90, and sine of 90 is 1. Now, just to see if we did that right, we can always put this in the calculator, and you guys know I'm a big fan of the check. So I'm going to check this in my graphing calculator. Sine of 100 cos of 10 minus cos of 100 sine of 10 is 1 and sine of 90 is 1. So I know I did that correctly. Okay, next one. I want to write it as a single trig function and find the exact value. So this looks like a double angle identity. So 2 sine cos. So sine is something double mixed. So I know this is a sine double angle, which means it's sine of 2 times the angle. It's a double angle identity. So these are just applying all the formulas. So sine of 2 times pi over 12 is pi over 6. And I know that sine of pi over 6, which is 30 degrees, that's just a half. Again, always check on the calculator. This time I have to make sure my mode is in radians. So I'm going to plug in 2 sine pi over 12 cos pi over 12 and see if that's the same as a half. So 2 sine pi over 12 times cos pi over 12 is a half, which is the same as sine of pi over 6. So I know that I did that correctly. Okay. So for this next one here, I have cos pi over 3 cos pi over 6 plus sine pi over 3 sine pi over 6. So I'm back to the angle sum and difference. So I have the same trig value for each. So I know that that's a cosine because cosine is same trig mixed sine. So this is a cosine, and since it's a mixed sine, instead of adding, it's actually subtracting. So it's going to be pi over 3 take away pi over 6. So if you want to do that in your calculator, you can take pi out and then put pi back, which is 1 over 6. So you can put pi back. So this is the same as cos of pi over 6, which is 30 degrees, and cos of pi over 6 is root 3 over 2. Again, I want to check on the calculator to see if this whole thing is actually equal to cos of pi over 6. So putting that into my calculator, I can see that cos pi over 3 cos pi over 6 plus sine pi over 3 sine pi over 6 has the same value as cos pi over 6. So I know I did that correctly. Okay, for this one here, I want to find the exact value of tan of 15. So when I look at all of the angles on the unit circle that I can use, I want to try as much as possible to use angles where in this case, tangent will be positive. So tangent is positive in quadrant number 1, and this is quadrant number 2. Quadrant number 3, tangent is also positive. And when I'm talking about that, I'm talking about the cast rule. So because I'm dealing with tangent, I want to keep everything positive. So I'm going to work in quadrant 1 and quadrant 3. So I just kind of look to see what can I do adding or subtracting to combine this to be 15 degrees. So I know that, for example, if I take 45 degrees and 30 degrees, and I were to subtract those, I would get tan of 15. So I know that tan of 45 degrees minus 30 degrees, that's going to give me tan of 15. So I'm going to use my tangent formula. So this is going to be tangent of 45 minus tangent of 30 all over 1 plus tan 45 tan 30. So this is where knowing your unit circle or using your hand trick, whichever you use, to figure out the exact values is really important. So tan of 45 is 1 minus tan of 30 is 1 over root 3 all over 1 plus 1 times 1 over root 3. So this is 1 minus 1 over root 3 over 1 plus 1 over root 3. So whenever I have fraction over a fraction, I can never leave fraction over a fraction. So I always just multiply by the denominator. So distributing that inside the brackets, I'm going to have root 3 times 1, which is root 3, minus the root 3's cancel 1, over root 3 times 1, plus the root 3's cancel 1. Now, it's okay if you leave it like this, but remember the curriculum says that we need to be able to recognize both ways of doing it. So what I want to do is let's take this and actually rationalize the denominator so you can see both ways. So this answer is okay, but I also want to look at rationalizing the denominator. So looking at this here, let's rationalize the denominator. In the denominator, I have a binomial. So I will multiply numerator and denominator by the conjugate. So here, root 3 times root 3 is 3, minus root 3 times 1, minus root 3 times 1. Negative 1 and negative 1 is positive 1. All over, root 3 times root 3 is 3, minus root 3, 1 times root 3, and then 1 times negative 1. So 3 plus 1 in the numerator is 4, minus 2 root 3's, all over, these cancel, 3 take away 1 is 2. And then factor out 2 from everything, divide everything by 2, and I'm going to have 2 minus root 3 is my final answer. So again, either answer is fine. So I just want to check, and I checked using my first version of the answer. So tan of 15 is the same as root 3 minus 1 over root 3 plus 1. They both match, so I know I did that correctly. Okay, let's try this one. So tan of 11 pi over 12. So I have all my radians on the side, so I have to think about numbers that combine together to get 11 over 12. So doing this is a little bit more challenging because now I'm having to visualize adding fractions in my head. So I can go through and do that. Like I know that it's probably going to be a denominator of 4 and a denominator of 3 because that combines to be 12. And I can try a bunch of different combinations that work. Or I can just switch to degrees. And I'm fine with you guys doing that. So for angle sum and difference, it's way easier to work with degrees than trying to add radian fractions in your head. So there's no value to keeping it in radians. Let's just switch it to degrees. So we're going to go from radians to degrees. So I'm going to take my radians and I'm going to multiply it. Since I'm going 2 degrees, I want my degrees on top, 180 over pi. So of course my pi's cancel. So I end up with 11 times 180 divided by 12, and that's just 165 degrees. So let's work with 165 degrees. That's way easier than dealing with all those fractions. Okay, so I'm dealing with tangent. Remember last time I told you I want you to deal with where tangent is positive. So it's positive in quadrant 1 and in quadrant 3. You don't have to use those quadrants, but I really recommend, if you can, I would definitely try and use quadrants 1 and 3 because tangent is positive in those quadrants, so it makes it just a little bit easier. So I'm trying to combine to 165. So what I'm going to do is I'm going to take 225 and I'll take 60 and I'll subtract them. So tan of 225 take away 60, that gives me 165. So applying my formula, I have tan of 225 minus tan of 60 over 1 plus tan of 225 tan of 60. Okay, so looking at this, tan of 225, that's 1, minus tan of 60 is root 3, over 1 plus tan of 225 is 1 times tan of 60 is root 3. So this is just 1 minus root 3 all over 1 plus root 3. Okay, so just like we did in the last question, it's okay if you leave it like that, but it's also okay if you guys rationalize it. So what I want to do is let's take this question or this answer and we'll actually rationalize it so you're comfortable seeing both ways of doing it. So going over here, let's rationalize the denominator. So this is quite similar to that 15-degree one that we did. We just had root 3 minus 1. Now we have 1 minus root 3. So it's the same idea. Okay, so rationalizing the denominator. I'm going to multiply by 1 minus root 3, and I'll do it to the numerator and the denominator to be fair. So in the numerator, I'm going to have 1 minus root 3 minus root 3 plus 3. In the denominator, I'm going to have 1 minus root 3 plus root 3 minus 3. So this is 1 plus 3 in the numerator, 4 minus 2 root 3's over 1 minus 3, negative 2. So let's divide all of our terms by negative 2, and we'll get negative 2 plus the root of 3. Okay, so what I want to know is tan of 165 the same as 1 minus root 3 over 1 plus root 3, or my rationalized answer? So you can see I put it in my calculator, and I get a match, so I know that I am correct. Okay, so I just want to switch gears a little bit and try this question here. So this question here, we're going to use this information and answer 3 questions based on this information. So we have the cos of x equals negative pi over 3, where x is in between pi over 2 and pi. So really, that just means quadrant number 2. And they want us to find cos of 2x. So cos of 2x, 3 different formulas that we could use. Now, I'm already given that cos x equals negative a third. I'm not given anything about sine. So I don't want to use this one, and I don't want to use this one, because then I'd have to find sine. So I'm just going to go with the middle formula. So cos of 2x equals 2 cos x squared. So cos x is negative a third, and that'll just be squared minus 1. So that's 2 times 1/9 minus 1. So 2/9 minus 9/9, which is really 1, is negative 7/9. So that's my answer. Okay, let's now look at same information, but now we're going to find sine of 2x. Okay, so now unfortunately I have to go and try and figure out what sine x is. So I can't avoid it because I need a sine x in my equation. So I'm going to use the fact that I know cos of x is negative a third, and I know it's in quadrant number 2. So I'm just going to draw my triangle. And then what I'm using is Pythagorean theorem to find the missing side. So negative 1 squared plus y squared, I'm solving for this side, equals 3 squared. So I get 1 plus y squared equals 9, subtract 1 from both sides, and I get y squared equals 8. So y is equal to, now it's really plus or minus, but because in quadrant 2 y is positive, that's why it's just the answer of 2 root 2. Had I made that question in quadrant 3, y would have been negative. But because it's in quadrant 2, y is positive. So now that I know that, I can figure out what sine of 2x is by applying my formula. So sine of 2x is sine 2 times sine of x. So sine of x, y over r, 2 root 2 over 3, times cos x, which is x over r, negative 1 over 3. So let's just put that over 1 so we have fractions for everything. So in the numerator, I have negative 1 times 2 is negative 4 with a root 2 over 3 times 1 is 9. So that would be my final answer, negative 4 root 2 over 9. Okay, so over here we're just going to find tan of 2x. So I've already used Pythagorean theorem to find my missing side. So now let's do tan of 2x applying the formula. So tan of 2x equals 2 times tan of x. Tan of x is y over x. So that's 2 root 2 over negative 1, which is just negative 2 root 2. And that will be all over 1 minus tan of x squared. Well, tan of x again was negative 2 root 2, and that will be squared. So I'm just going to write it out twice. So tan of 2x equals 2 times negative 2 root 2 is negative 4 root 2. 1, and then here I have minus, negative times a negative is a positive. So 2 times 2 is 4. Root 2 times root 2 is 2. So it's really 1 minus 4 times 2. So tan of 2x equals negative 4 root 2 over 1 minus 8 is negative 7. Two negatives make a positive, so really this is like 4 root 2 all over 7. Okay, so that's the end of this lesson. I just wanted to summarize this with you. When working with double angle identities, look for your patterns. Remember, sine was double mixed, and cosine is always something squared. When working with angle sum and difference, it's always easiest to work in degrees, and look for your patterns again. Sine is mixed trig, same sign. Cos is same trig, mixed sign. So right now you guys have a lot of identities on your formula sheet. So I really want you to keep your formula sheet in a safe place because I want to protect yourself from identity theft. Very important. Okay, I want you guys to do practice questions number 1 through 5. Again, the detailed solutions are on D2L. I hope this video helped you, and I'll see you for the next one.